We're talking about translating languages, as you've seen. I'd like to introduce the project done at the University of Applied Sciences in Rapperswil, Switzerland. After the introduction, we're looking at the coarse-grained structure of the software, how we can handle the differences between the target languages we support, then we're going to dig down to some selected solution details. I'll show you a short view to a GUI we developed, essentially to test the whole thing. And as conclusions, we're having conclusions and an outlook. What can be done with the software in the future? Okay. The project was essentially a diploma thesis at our university. It was an 8-week project with 2 persons. The software was written on behalf of PDF Tools Switzerland and tailored to their needs. So academically, it probably doesn't cover all interesting spots, but we try to cover their needs. The project includes a concept and a demo application as a proof of the concept, just to put your expectations into the right scale. Why would someone want to produce code in other languages based on a source language? Well, usually developers like to write code for libraries working in their environment, and not just for libraries written for other environments with wrappers around them to try make them fit. It eases the code maintainability if the translator is written correctly. The code quality can be maintained over all languages supported. The development costs will obviously be smaller than if you have to develop this code in several different languages. And last but not least, debugging is easier because you only have to debug one language instead of several ones. Well, the concept introduces a new source language, A#. Basically, it is modified C#, but just to refer to it easier, we renamed it to A#, so people know at once, is it plain C# or is it simplified C# used in our project. We covered 3 target languages, C#, Java, and C++. As you might guess, the translation from A# to C# is quite trivial. So the proof of concept covers as only target language, not C# but Java. We've implemented a GUI to test the software and to demonstrate it. The whole software was written in C# and .NET 1. The overall goal was to translate only the language and basic concepts, not the whole class library. Coarse-grained structure is cleaved into two big parts, the front end and the back end. The front end might be familiar to you since it's basically the structure of a compiler. In the back end, we're going to translate the parsed code into different target languages. The scanner and the parser were not developed in this project, but are third-party software by Peter Messenbeck of the Linz University in Austria. But the parser had to be configured. That is, a grammar had to be written. After parsing, we're going to have a look at semantic analysis. And in the back end, we're transforming the tree into a target language specific tree, and in the end generate target code. While the differences in the different target languages can be handled in different ways. First of all, you could omit just the critical spots of the languages so that the developer in H# has to write the code himself. While this is feasible in many parts, it is often not wise to do. So you could provide an own solution upon target language creation. That is, after generating of the AST, you introduce in the tree transformation those constructs. Or you can provide a runtime library, so you implement the whole thing in the target languages. There are many differences in those targets we support. First of all, there are different language constructs. Data types, simple data types, are not the same, such as unsigned types not available in Java, or type precision in C++, which is usually compiler dependent. Missing auto-boxing in C++, for instance. Class libraries have different capabilities. And last but not least, the runtime environment is also different, such as the missing garbage collector in C++. So let's have a look at some details of the solution. If you take that line of code with a property in C# or H# in that case, and you just syntactically translate it to Java, you'll get the line at the bottom. But is that really what you need? Since Java does not implement properties, that is of course not correct. So you have to introduce a setter or getter method there. But first you have to know that this is actually a property and not a field of the object. So semantic analysis is a must at this point. This involves the registration of the different types in a declaration space and resolve those types and symbols when they're used in the code, as we've seen before. Another example would be the import statements. Since H# or C# has its using statement, which imports whole namespaces and namespaces hierarchies, but Java does import single classes. Therefore, the import statements cannot just be taken over from C#, but have to be rewritten from scratch. One of the goals of Hydra is to translate a valid program in H# to a valid program, to a semantically identical program in the target language. If the source code is not valid, the target code also cannot be valid. So the semantic analysis is necessary to decide if the source code actually is valid or if it is not. When we have a look at the tree transformation, then the AST is, in our case, transformed destructively into a target language dependent tree. This also could be done differently, but in our project we decided to go that way since we didn't know if the whole structure, we're talking about millions of lines of code here, could be held in memory a second time when we have to put up another tree. So the nodes are reordered. Some subtrees are removed in its entirety and replaced by other subtrees. The tree traversal is implemented by a visitor pattern. Error handling and reporting is also a very important feature because a developer has to see his errors and should be pointed at the right line where he has to correct it. So errors have to be found as early as possible, not only in the target language but also in the source language. As many errors as possible should be shown at once, so that not for every error a single pass is necessary to find it. But processing should not stop when an error is found. Error reporting actually is done in the software in all main components: parsing, semantic analysis, transformation, and code generation, to virtually find every error that is in there. The solution is extendable. It is possible to add another backend. To write another backend, two interfaces have to be implemented. This is I-transformation and I-code generation. So the API for the backend should be as simple as possible. We've developed a GUI that you can see here. First of all, to test the software. But as you can see, the project leads further. You can do codes highlighting, code analysis as shown in the tree view here. So it can be used as a component for other software projects. To conclude the presentation, a translation from a source language into different target languages at once is possible, however often not trivial. Even languages that seem similar as C# and Java have differences that are highly untrivial to come over. The existing Hydra code is not a production proof code, if you want to put it that way, but is a proof of concept. It includes a compiler front end, which, as said before, can be used as base for other projects, such as code analyzers, intelligent line, code line counters, and on, you name it. Well, what can be done with that software? It can be used for cross-platform debugging, possibly. One other goal would be to support more general cases, so possibly more of the libraries of the languages, probably to implement non-destructive tree transformation, because at the moment, for every target language, a reparsing of the source code is necessary, which, as you might suppose, leads to longer processing times. The range of supported languages could be broadened by means of other backends. There are actually some Hydra-based projects in discussion at the moment, such as C#, VB.NET language translator, or a semantic code analyzer like ReSharper in Visual Studio, and possibly others. So if there are any questions, just let me know, and I'll be glad to answer them. Yes, please.
In translating at the level of the language, things like conflicts in basic data types, have you found, how have you overcome the problem of avoiding simulating the type that's unnatural in the target? Have you been able to abstract away from what that's used for, so you can find a more natural use of a target data type?
Well, actually, we're not abstracting here. We're using C# data types, and we're mapping them to target language data types that are available.
What you do when there's not one available?
Sorry?
When there is not such a target, there's not an easy correspondence between.
Well, actually, we use similar data types, probably data types that can hold more or bigger numbers or whatever. Use those. And if there is none available, we're implementing own solutions. Other questions? Yes, please.
I've never done the translation, of course, but there are other packages out there that
Right.
open or free compared your project against what's available.
No, we didn't make any comparisons. Actually, even with the .NET framework, you could translate from one source language to another. If you translate it to IL and port it back to, possibly from C# to IL and back to VB.NET. But you still stick to the .NET framework in that case. And we wanted to have a solution that was not dependent of some environment libraries of that sort.
I guess I focused on that when I saw your bullet down below that said C# VB.NET.
Right. Right. It should not be dependent on, for example, the .NET framework. It should be generally usable for any target language. Yes, other questions? If there are none, I'd like to finish here as I see you're not only mentally but also physically hungry. I'd like to finish that last pre-lunch presentation. Thank you.